A very good day to everyone. My name is Nelson Maurice, son of Anne Anthony. My matrix number is 01DKP23F2006. Today we are going to talk about the basic construction of the medium speed and high speed marine diesel engine. And here is my group members list. The first one is Sugenda Wanalaki Aridal, and the second one is Falamani bin Afendi. The third one is Darwin Analaki Ahmed, and the fourth one is Pavitran Kisubramanian. So for today's discussion is mainly about how does a governor regulate engine speed automatically, and what are the main components of the lubrication system, and how do they function, and how does the piston cooling system help to reduce the engine operating temperatures. Introduction to the marine diesel engines. Marine diesel engines are essential for powering the ships, offering high efficiency and long operational life. These engines are classified based on their speed. Medium speed engines typically operate between 250 to 900 rpm, while high speed engines run at above 900 rpm. Medium speed engines are commonly used in ferries, large vessels, and cruise ships, while high-speed engines are suited for smaller vessels such as patrol boats and generators. So in today's presentation, we will focus on the three important systems that will ensure the reliable performance on these marine engines. The first one is the governance system is automatically regulate the engine speed according to the load condition. The second one is a piston cooling system. This is maintain the safe piston temperatures during the engine operation. And the third one is the lubrication system. It's reduce the friction and minimize the wear and help in heat dissipation. Okay, now let us see the governor regulates engine speed, which is governor system is automatically speed control. A governor is a device to design to control the speed of the diesel engine automatically without the need for the constant human intervention. Its main function to ensure that the engine maintain a steady and safe RPM regardless of load's variation. When the load on the engine increases for or decreases, the governor responds by adjusting the amount of fuel being supplied to the engine. So there are two common types of governors, which is the mechanical governor and the electronic governor. First, let's see the mechanical governor. Mechanical governor it operates using rotating flyweights connected to the engine crankshaft. Here we mention the flyweights as a flywheel. These flyweights, which is the flywheel, move outward with increased speed, adjusting a control mechanism to reduce the fuel input. So the electronic governor is mainly utilizes sensors and ECU, which is electronic control unit, to detect the changes in the engine speed and electronically manage fuel injection. So now let us see the key benefits of the governor. It's prevent the overspeeding and potential engine damage, and then maintains the smooth performance under load changes, and improves fuel efficiency and reduce the emission. And lastly, it's enable automatic control and reducing needs for the manual adjustment.
Hello everyone, my name is Sugendra Analalaki Rao. My matrix card number 01DKP23F 2001. I'm from Polytechnic Unkoma. Today I'm going to talk about what are the main components of the lubrication system and how do they function. So the main component of the lubrication system are the oil sump, oil pump, oil filter, oil cooler, oil galleries, and oil lines. These components work together to circulate and deliver oil to engine parts, reducing friction, cooling components, and preventing wear. And the function of each component is the first one is sump, oil pan, or oil tank. The function is toss the lubrication oil. In smaller engines, it's actually an oil pan under the crankcase. In large marine engines, a separate oil tank drive sump system is often used. And the second one is oil pump. And the function is circulates oil throughout the engine, usually gear or screw type, driven mechanically or electrically. Ensure oil reaches all parts under pressure. And the third is oil filter. And the function is remove impurities, metal particle, carbon and etc. from the oil. Helps prolong engine life by preventing abrasive particle from damaging engine parts. And the fourth one is oil cooler or heat exchanger. And the function is regulates the temperature of the lubrication oil. Use seawater or fresh water as a cooling medium and prevents oil from becoming too thin at high temperatures or too thick at low temperatures. And the fifth one is pressure relief valve. And the function is prevents excessive pressure in the lubrication system, opens by bypass oil if pressure exceeds safe levels. And the sixth one is lubrication oil lines and passages. Then the function is channels oil to various parts like main bearings, crankshaft, camshaft, piston, and the turbocharger if fitted. And the seventh one is oil mist detector in large engines. And the function is monitors for the presence of oil mist in the crankcase, which could signal a potential explosion risk due to a bearing failure or overheating. That's all for me. Thank you.
Okay, next. My name is Darwin Anadakyanandan. My metric card number is 01DKP 23F2004. Now I'm going to talk about how lubricant systems work. Oil is stored in the sump or oil tank, and then the oil pump draw the oil and send it through the oil filter. And filter oil is then sent through the oil cooler to maintain optimal temperature, and then the pressurized oil flow through galleries and passages to lubricate engine components. Finally, the oil return to the sump or tank and the cycle repeats. Okay, now I'm going to explain about why it's important in marine engines. Firstly, reduce metal to metal contact, preventing wear. The second one is help in dissipation from engine parts. Thirdly, aids in sealing piston rings and cleaning engine components. And the final one is especially the critical in large, slow speed diesel engines which operate under high loads and extended hours.
Assalamualaikum warahmatullahi wabarakatuh and selamat sejahtera. My name is Aiful Amani bin Afendi, matrix number 01DKP 23F2011, and today I'll be talking about the piston cooling system. Basically, the piston cooling system reduce the localized heat stress and protects the engine components and contributes to the overall thermal stability of the engine. They're especially important in turbocharger, high compression or high speed engines. Alright, so now we'll be going over how does this piston cooling system help reduce the engine operating temperatures. Well, first off is direct cooling of the pistons. By heat absorption, the oil absorbs a significant amount of heat generated during a combustion from the pistons, which are among the hottest components in the engine. Other than that is the prevention of the piston overheating. pistons operate under extreme conditions and without proper cooling, they can overload, expand excessively, and cause seizure or scuffing against the cylinder walls. Finally, is the better thermal management overall. By reducing the heat load on the piston and indirectly on the cylinder walls and head system, it helps the entire system maintain a more stable operating temperature that leads to a better efficiency, lower emission, and longer engine life.
Hello everyone, a good wishes from me. My name is Paudran Alex Subramanian. My matching number is 01DKB23F2003. Here I'm going to talk about why piston cooling system is crucial. Firstly, high thermal loads. In medium and high speed in diesel engine, the combustion process is rapid and instant, generating very high temperature. The piston crown, being close to the combustion chamber, is exposed to the extreme heat, especially during continuous high load operation. Without cooling, this heat will be cause the thermal stress, deformation, or even piston seizure. Secondly, improved durability and reliability. A well-designed piston cooling system extends the life of the engine components by reducing thermal fatigue, carbon buildup, and localized hot spots. This contributes to lower maintenance costs and longer overall intervals. Last but not least, enable higher performance. Efficiency piston cooling allows the engine to operate at higher compression ratios and combustion pressure, which are key to achieving higher power output and efficiency. Alright, now here we have type of piston cooling system. For the firstly, oil jet cooling under piston cooling, most common method in modern engines. Secondly, cooling galleries inside the piston crown circulates oil to the remove heat directly from the crown area. For the conclusion, the efficient operation of an engine relies heavily on systems that automatically regulate performance and maintain optimal conditions. The governor plays a crucial role in automatically controlling engine speed by adjusting fuel supply based on load changes. The lubricant system, consisting of components such as the oil pump, oil filter, and oil passage, ensures that engine parts move smoothly with minimal friction, reducing wear and extending engine life. Meanwhile, the piston cooling system dissipates excess heat from the pistons, helping to maintain safe operating temperature and prevent engine overheating. Together, these systems work in harmony to exchange engine efficiency, reliability, and longevity. That's all for now. Thank you from us.